Okay, here we go in section 5.2. Woohoo! Here we go. So your learning objectives are you're going to describe chance behavior with a probability model, define and apply basic rules of probability, determine probabilities from two-way tables, construct Venn diagrams, and determine probabilities. All right, so a sample space is just all the set of possible outcomes that could happen. And then a probability model consists of all the sample space things that could happen with the probability for each of those events happening. So, give a probability model for flipping a coin 3 times. So here's our sample space. Head, 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 tail, head, head, tail, head, etc. So, whoops. So the probability model, then I would have to give, so these are the events, and here's the probability of the events happening. This would be a 1 out of 1, 2, 3, 4, 5, 6, 7, 8. This would be a 1 out of 8, 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 1 out of 8. And then I could ask you a lot of other questions about this if I wanted to. All right, so fill out the dice chart for the sum. Some already filled in. So if you roll 2 dice, and so 1 and 1 would give you a sum of 2, etc. And you can fill it all in. So after having that, let's look at the probability model for the chance process of rolling 2 fair 6-sided die. That's 1 tan and 1 split. So here's your sample space, 36 outcomes. Since the die are fair and each outcome is equally likely, each outcome has a probability of 1 over 36 appearing. So an event is any collection of outcomes for some chance process. That is, an event is a subset of the sample space. Events are usually designated by capital letters, A, B, C, and so on. So if A is an event, we would write the probability of A like this. So P parentheses A parentheses. And the dice rolling example, suppose we defined event A as the sum is 5. So then I may ask you, there are all the different ways it could happen, what is the probability of A? Meaning, what's the probability that you get a sum of 5? Well, there were 4 ways out of 36, so you'd have 4 out of 36. If you wanted to reduce that, great. If you wanted to put that into a percent, great. If you wanted to put it into decimal, great. But you can leave it. So then it says, suppose event B is defined as the sum is not 5. Well, we know the total probability has to be 1, and if we know the probability of it being 5, how would we find the sum is not 5? We would subtract the probability of 5 from 1. All right, see if you can do this. Roll 2 fair die, and what's the probability that the sum is 4? And you can look on your chart and see if you get all of those. If that went too fast, go back and pause me so you can see if you get that. All right, basic rules of probability. The probability of any event is always between 0 and 1. All of the probabilities added together have to sum to 1. If all outcomes in the same sample space are equally likely, that the probability of A occurs can be found by using the following formula. Number of outcomes corresponding to A divided by the total number of outcomes. Okay? The probability that it does not occur is 1 minus the probability that it does occur. And if 2 events have no outcomes in common, remove this, the probability that one or the other occurs is the sum of their individual probabilities. Now, on your formula sheet, you have, I think, 3 different formulas underneath probability that you can always use, and you definitely want to open that up when you start to do with those. All right, mutually exclusive means that they have no outcomes in common. So, being a boy and being a girl. These are mutually exclusive. Being a 9th grader or being a 10th grader. These are mutually exclusive. You can't be both at the same time. So basic rules of probability. We know that they're between 0 and 1. All of this we've already seen, so you can look over it. All right, so let's learn some more things with the Venn diagrams. A complement. So if you have the complement, it's usually denoted with a little c above it. It's the opposite of what has occurred. So it's just 1 minus the probability of it occurring. Addition rule for mutually exclusive events. If A and B are mutually exclusive, A or B is the same as a union, and you can look. If they have nothing in common, it's just A, probability of A, plus the probability of B. Now, if, I'm going to go back here for a second, if they had overlap, if they have something in common, then you're going to then have to subtract the probability of A and B because you would have counted that part twice. All right, so let's look at this guy. Distance learning courses are rapidly gaining popularity among college students. Randomly selected undergraduate students who's taking distance learning courses for credit, and then they record the student's age. And here's your probability model. So the age groups and the probability that they were taking that distance learning course. All right, so show that this is a legitimate probability model. So you're going to have to add up all the probabilities. And what do they need to total? Good. They have to total 1. And they do. Oops, went too fast. Okay. Find the probability that the chosen student is not in the traditional college age group. So they selected somebody and they were not in the traditional age group. So here you'd add up those 3. Or you could just take 1 minus the 0.57, and you'd get the same thing, 0.43. Randomly select a student who took the 2010 AP Statistics exam and record the student's score. And here's the probability model. Show that it is a legitimate probability model. So again, you're going to add up all of these values, and they have to total 1. And that's how you would show it. And then find the probability that the chosen student scored a 3 or better. So you could either add up those 3, or you could do 1 minus those 2. I'll let you try this one. Look through it. So why are events A and B mutually exclusive? What does A or B mean in basically plain language? And if C is the event that the person chosen has normal cholesterol below 200, what's the probability of C? So see what you can do. So basically you cannot have a cholesterol of 240 and also have a cholesterol between 200 and 239. So these are mutually exclusive events. So the probability of A plus the probability of B, so you're going to add up the probability of both of them occurring, and they told us right here. So the probability of A and B, since they're mutually exclusive, you just add them together. Then you can see what's left over, so 1 minus what you already have, to get the probability of it being normal. Okay, see if you can do this one. Okay, so part A has pierced ears, so the probability that they have pierced ears would be 103 out of the total 178. B, male and pierced ears, meaning they have to have both. Well, the only place where they have that they're male and they have pierced ears is the 19, again out of the total. The next one is a male or has pierced ears. So in this case, I would have to take this total and this total, but I had this as an overlap in common, so I would have to subtract that from the overlap and then divide by the total. So I could have 90 plus 103 minus 19 over my total of 178, because this would have been counted both in here and in here, so it would have been counted twice. All right, so here's another Venn diagram when you have overlap and common. You can't just add the whole A plus B, so you have to subtract out what they have in common, otherwise you will have counted it twice. So let's look here. See if you can do this one. Probability that you're high school graduate and own a home, high school graduate or owns a home. And this is what you should get. See how you did. If you have questions, let me know. Here you have all of these formulas again on your AP formula sheet, so go under the probability section. And this one and this one you're going to be having. So again, this little guy means or, and this guy means and. Okay? When you're dealing with these. All right, so just some things we've kind of seen: mutually exclusive, complement. So the intersection, A and B, is the area in common. A or B, the union, would be everything in A or B. Okay, so you would take it all. Whereas the intersection here is just what they have in common. So to kind of keep the symbol straight, you can think the union, the U, and the intersection and the in intersection for the and. Okay, so back to your pierced ears example. Oops. What if I wanted you to make a Venn diagram of the situation for male and pierced ears? All right, so male is A. So the first thing you're going to do is start in the middle here with the 19. So this is male and pierced ears. Then what's left for the males? Well, I would have 71 left. What's left for the pierced ears? I would have 84. Then I said, well, all of these added together, and then I know I have a total of 178. So what's left that I didn't have? 4. So let's say I wanted you to find some of these. I kind of put it in words and in symbols. What's the probability, or no, what's the amount, sorry, the count for having male and pierced ears? Move this. So male and pierced ears would be the intersection right here, which would be 19. Okay, so what about they are male? Let's go to the next one. Sorry, male, but they do not have pierced ears. So male, but do not have pierced ears would be the 71. Okay, let's look at the next one. Female and pierced ears. So they have to both be female and have pierced ears. So they're not an A, intersect with B. So that would have to be right here, 84. And then female and no pierced ears. Whoops, so it's not an A or it's not in B, and that would be your 4. All right, make a Venn diagram for the following situation. Out of 40 students, 14 are taking English, 29 chemistry, 5 are in both classes. How many students are in neither class? How many are in either class? What is the probability that a randomly chosen student from this group is taking only chemistry? So when you take and make a Venn diagram, always start in the middle. So how many are in both is 5. And we have English and chemistry. So then how many are taking English total are 14. Since we already have 5, then we have 9 left. 29 are taking chemistry total, and we already have 5, so we have 24 left. Now it tells us that this is out of 40 students. So how many do we have so far? Let's add it up. 9 plus 5 plus 24 is 38. So I know I have 2 students left who didn't fit into either one of those circles. All right, so how many students are in neither class? That answer would be 2. How many students are in either class? We said that that was 38. And what is the probability that a randomly chosen student from this group is only taking the chemistry? Only chemistry is 24 out of a total of 40. And again, if you want to reduce that, great. All right, make a Venn diagram for this guy. Oh, that's what we just did. I don't know why that's on there again. Okay. According to the National Center for Health Statistics in December 2008, 78% of U.S. households had a traditional landline telephone, 80% had cell phones, and 60% had both. Make a two-way table, make a Venn diagram, then find the probability that the household had at least one of the 2 types of phones, and find the probability that the household has a cell phone only. All right, so kind of starting it out like this. So I'm going to let A be a landline. B is going to be my cell phone. And we're going to fill in all that information. So if you want to go back and get it, said 78% had landline, 80 had cell, 60 had both. All right. So I always like to do Venn diagrams. I think they're easier, and then we can fill in the rest. So I know that 60% had both would go in the middle. And then if it was 78 had a landline, then I take 78 minus 60 and I can see I had 18% left. If 80% had a cell phone, then I'm going to take 80 minus the 60 and I have 20 left. Adding this up, I have 98 so far. So I have 2% left without either. And again, we can fill all this into the two-way table, having both, and then the 20 left over that we found, and we said it's a total of 80. Only having a landline was at 18. No landline and no cell phone would be 0.02, and you can fill in all of those guys. So then, finding the probability of A or B, you're going to add them all up. So basically, you can add 18%, 60%, 20%. Or you could do your 0.78 plus your 0.8 minus 0.6. And then what's the probability that they only have a cell phone? That was the 20%, which we can see right there. So that's the end of section 5.2. Here are some of your summaries. And we're going to pick up in section 5.3 next.